Hello again. In this part of Unit 7, we're going to discuss the meanings of the new symbols. So just to remind you about the meanings of the old symbols, the negation symbol, its meaning is displayed with this truth table, which tells us that if square is true, then not square is false, and then that if square is false, then not square is true. And so not square has the opposite truth value of square. And that's really all there is to say about the meaning of the negation symbol. That exhausts its meaning, that the way its truth value is determined by the truth value of what is negated. And similarly with the if we remember, if the antecedent and consequent are both true, then the conditional is true. If the antecedent is true and the consequent is false, then the conditional is false. If the antecedent is false and the consequent is true, the conditional is true. And if the antecedent and consequent are both false, then again the conditional is true. And so one way we can think about what the conditional means is, yes, is it the case that circle is true, but is it the case that square is true but circle is not? No, that's not the case. That's what our formal conditional means. So it's false on line 2, but it's true otherwise. So let's look at our new symbols. So we have and this has the pretty obvious truth table. If square is true and circle is true, then square and circle is true. If square is true and circle is false, then square and circle is false. If square is false and circle is true, then again square and circle is false. And finally, if both square and circle are false, then square and circle is false. And that tells us what the meaning of the conjunction is. It's true if both of its conjuncts are true, and it's false otherwise. What about or? So we say that if the square and circle are each true, then square or circle is true. If square is true but circle is false, then square or circle is true. If square is false but circle is true, then the whole thing is true. And if square and circle are both false, then the whole thing is false. So the whole thing is true if either the first disjunct or the second disjunct or both are true. If both disjuncts are false, then the whole thing is false. Now it's worth noting for a minute here. We have, in English, there may be two different kinds of or, what we call an inclusive or an exclusive or. So if you go to a restaurant and you order a meal and it comes with a side dish, they'll say it comes with soup or salad. But you don't get to have both. You get to pick one or the other, but not both. Whereas with the inclusive or, I might ask, and so if the waiter says to you soup or salad and then you say both, the waiter gives you a bad look. Whereas if I ask you, are you free at 4 or 5, you might say, oh, I'm free at both those times, and then I would say, okay. So in the soup or salad case, the or is in some sense understood exclusively. It's true if one or the other is true, but it's false if they're both true. In the inclusive sense, it's true if either one is true and the other is false, or if both of the disjuncts are true. And we will always understand or in the inclusive sense. That's just how we're going to use that symbol. And our or is the inclusive or. It's true if both of them are true, if both the disjuncts are true. And we will treat all ors in English as inclusive and is symbolized by this, by the V in our logical language. Now, this might be kind of, in treating all English ors as inclusive, we might be doing one of two things. It might be so if you think about the conditional, if you remember the conditional, we saw in the previous unit that the conditional in natural language probably doesn't, in at least some cases, have the same meaning as our arrow in the formal language. And we said, well, we're going to ignore that difference in meaning. And so we're going to give symbolizations that are maybe a little bit, in some sense, not perfect. That may be what's going on when we symbolize with or, with the English ors with our V symbol. But there may be other things going on. It may be that the exclusion is not part of the literal meaning of the word, but is there's something else going on. We're not going to worry about that, what might be going on exactly. We're going to treat all English ors as if they're inclusive. The last symbol is the double arrow, the if and only if, IFF. So if both square and circle are true, then square if and only if circle is true. If square is true and circle is false, then the whole thing is false. If square is false and circle is true, again the whole thing is false. But if square and circle are both false, then the whole thing is true. And so the truth table says what the truth table tells us, and there's nothing about conditionals here. It just says that the biconditional, that square if and only if circle, is true. It's true if whenever the components have the same truth value, and it's false when they have different truth values. Now, as it turns out, we can read square if and only if circle as meaning square if circle and circle if square, and as it turns out, the two conditionals are both true if square and circle are both true, and the two conditionals are both true if square and circle are both false, and if square and circle have different truth values, then one of the conditionals is false. So one way of saying what square if and only if circle means is saying it means the same thing as square if circle and circle if square. A different way of saying what it means is that square and circle have the same truth value. Those are different ways of saying the same thing. Okay, so those are the truth tables for our new symbols for and, or, and if and only if. Or and is true if both of the components are true and it's false otherwise. Or is true if one, the other, or both of its components are true, it's false otherwise. And the biconditional is true if both components are true or both components are false, and it's false otherwise. So those are our new symbols. We've talked about the grammar and the meaning. In the next video, I'm going to talk about the inference rules for our symbols.